Hi everyone. So today we are going to solve some problems. So Chitresh here solved some three questions yesterday from the Leetcode contest. So first we will go through his solutions and try to understand his logic process. Then we will try some more questions in Leetcode. So Chitresh, can you share your screen so that we can understand your approach to the solutions?
Yes, yes. Okay, so this was the contest I participated, weekly contest 225.
Oh, you have to share your screen? Yeah, great. Yes.
Yes. Yes. So I was able to solve three problems.
That's really good.
Yeah. Yes. So the first problem is latest time by replacing hidden digits. Yeah. So in this problem, we are given a time in like 24 hours format. So we are given this string. It contains like 5 characters. We have the hour and the minute separated by a colon.
Okay.
And in our input string, like we are at some positions, we are given this question mark.
Okay.
So we do not know like what number comes over there. So what we have to do is we have to replace this question marks. We have to replace this question marks to get like the maximum possible time.
Okay.
Like in this example, instead of this question mark, the best number which we can insert is 3.
Yes.
It will be like 2350. And in place of this question mark, we can have 5.
Okay, yeah. Because we cannot have 6 because 60 is not valid. We cannot have
Yes.
70. We need to make this number valid, right? Yeah.
Yes, yes.
Okay.
Yeah, so this first number will be less than 24 and this second number will be less than 60.
Yeah, so this like a easy questions in Leetcode. So I think you can go through the solution. There is nothing more
Yes.
complex in the question. Okay,
Yeah,
like
so I used-
before that, how would you approach the problem, Saurabh? How would you solve it? Let's discuss a little bit.
okay.
Yes.
Okay, like we can place some constraints, like the R value can go up to 23. Yes, can go up to 23, and the minute value can go up to 59. So here, okay.
Let's open the Google Doc and we can like try to like doodle there.
Yes.
Yeah.
Yes. So Saurabh, you can write there and.
Okay. So the first thing is given is 2, 10. I think it was this.
Yeah.
This was the first question. And for that, this is the hour, right? And this is the minute.
Yes.
So we can set a constraint like the hour, the maximum value can be 23, and for the minute, the value can be 59.
Yes.
So as we are having the first thing as 2, then we can decide like as this value is 2. So our value should lie between 20 and 23, and we will get the maximum from it. So we will place here 3. So that will give us the maximum time in hours. And for the minutes part, as we are having the first position as 0, we can check like what are the possible values and which is the largest. Like we can replace it with 1, 2, 3, 4, and 5 because 60 is not possible, and 5 is the largest. Therefore, we will get our time as 23 and 59.
Yes. Like how would I solve this problem will be I will have like 4 value for 4 position. The first can be 2 and you can write first can be 2 and second can be 4, no 3, and third can be 5 and fourth can be 9, right?
No, sir. But it can be a 19, no. Because if we have the first index as 1, the first position as 1, then the time can be 1959.
True. So we have to also consider like, okay, so we have to
multiple if conditions.
Yeah. So let's write down the conditions here so that we can understand.
Okay. If string of 0 is 0, then string of 1 can be from 0 to 9.
But it will be 9, right? Yeah. The answer will be 9.
Yes.
Okay.
If this is 1,
okay,
then s of 1 can be from 0 to 9.
Yes.
And if s of 0 is 2,
yes,
then the value of this can be from 0 to 3.
Yes, true.
And for the minute part, if s of 0 is 0, then it will be like from 0 to 9. Like in this case, the value of s can be 0 to 5, and here
it can be 0 to 9.
From 0 to 9. Yes.
Okay. I think this is the solution, right? Chitresh, there is something else in this. Okay.
Yes, like this is the solution. Like we have to try the best possible value.
Okay, then let's see your solution then.
Yeah. I implemented it using recursion. Like at every index I was trying like what all numbers can I insert.
Yes.
So
okay.
at beginning I considered like 0 0 0 0 like it is our answer, and using this backtrack function I tried all the possible times which are possible and updated this answer.
Okay.
If I find something better. So in this backtrack function I had 3 parameters. I sent this input which was given to us. Then the very first index, like we have to like change index 0. And I'm also passing this string answer and I'm passing it as reference.
Okay.
So like all the changes which are made over here will be reflected. Now if we reach at index 5, when we are done with making all the changes,
yes.
So I calculated like what is the R and what is the minute. If our R and minute are within the range, I am updating my answer.
Okay.
Answer string. And I am returning from here.
Yeah.
Like after index 5, we don't have to do anything. And like if we are at index 2, index 2 is that colon. And if we are at index 2, or if our character at that index is not equal to question mark, so we cannot change that. So I'm going like backtrack with time going to the next index.
Yes. Okay.
Index plus 1 and updating my answer.
Yes.
Now if we reach to this part of code, it means we have a question mark at this position. So I'll update this index with all possible numbers like 0 to 9.
Okay.
And then I'll proceed with this same recursion step going to the next index.
Okay. So like can you like take one example and do a dry run of the code, and so that we can understand how does the backtracking works?
Okay, yes, I'll do it. Let's take this example. Yeah, so in this I'll first have a call to this like backtrack. This is the given time. This is the string which is given to us. And I've declared my answer variable as the minimum possible.
Yes.
Yes, so I'll pass time, that is our input string, And first we will consider this index 0. So 0 and our answer. So when we come to this index, our second condition triggers that at this index we don't have question mark. So we do not update our answer. We don't change that particular character, but we don't change this character, and we go to backtrack of time, and that index become 1.
Yes, okay.
Now at index 1 we have a question mark. So at this point I'll make multiple backtrack statements.
Okay.
Yeah, in this our time will be, time will not change. No. Yeah,
time will change.
This step our time will change. Yeah. So I'll make it 2 0, then question mark 0. Like this will be the very first. Index will be now 2.
Yes.
And our answer variable will be getting updated. So first I've tried 0 at the first question mark. Then I'll be trying 1. Then I'll be trying 2 like this. I'll be trying up to 29.
Okay. But do you need to track 29? Because we can just, after 24, you can just break it, right? Because it's called pruning of the tree.
Yes. But like at that time I thought this condition will handle that.
Yeah, it's okay. That's okay. But it will be more optimized if you prune the tree, because you don't need to go after 24, So it's fine. It's a small test case, so it will pass anyway. We don't need to worry about it. But if the test case is very big, like we have a very big number of backtracking conditions, then it's better to prune the tree. Okay.
Yes, so like at this index 2 we have this colon, so I will skip that test. Now we can come to this question mark. So for this question mark also, like I'll first change this. I'll first change it to 0, and this index will be changed to 4, because once we skip this 2, we are at index 3. And from index 3 we will go to index 4.
Yes.
Yeah.
Okay.
So then instead of 0 I'll keep it 1. And like this will also change. Like these steps will be called for 0, 1, 2.
It's like DFS, right? It's like backtracking, so it will go back. Okay, but let's do it in the simple way, because it doesn't need to be this complex. So we can just do it simply, just checking if and else. Like sort of explained.
I think doing it in iterative way will be better.
Yeah. So let's quickly implement that in iterative way and pass the test case. Yes.
Okay, should I implement this?
Yes.
Okay. I think I can update this family. Yeah. Okay, so I'll remove this backtrack function. Okay, so what I thought is I'll try using in this way, like for int I is equal to 23, then I greater than or equal to 0, I minus. I'll check whether I can replace in time we can replace these first 2 characters with this or not.
Okay.
Yes, so here I have to check whether.
But let's do it the simple way. Like if the first one is 2, do it if and else. Sort of explained.
Yes, sir. We can assign the maximum possible value for each index, and if we find a question mark, then we put it there.
Okay.
Saurabh, you want to implement it or?
Just give me a minute.
Okay.
Okay, I understood. I'll implement.
Okay, then you can implement it. Okay.
Yes. So if time of 0 is equal to 0, yes. So I think what your approach says is if time of 1 is equal to question mark, we will say time of 1 is equal to 9.
Yes, exactly. Yeah, just a series of if else. That's it. Yeah.
Yes. Else we will not change the time.
Yes.
Else if time, and this will be double equal to, else if we have 1, so if time of, in this case we will have 2 if it is question mark.
If time of 1 is 1, then yeah, we will have 2. We cannot be like no, can it be 9 or 19?
Yes, 19.
Yes, we can have 19.
It can be 19.
So time of 0 is 0 or 1. We can like we can simplify it. Equal to.
This will be
in quote. Yeah.
Else we will have 2 only. So if time of 1 is equal to question mark, then our time of 1 will be 3.
Yes.
Just
23. Yes. And do the same thing for the minute. Yes.
Yes, same thing. And this will be third character.
Yes.
If it is 0, I think from for 0 to 5 we will have same condition. So I think we can use if it is greater than.
If time of like 4, 0, 1, 2, 3, 4 is equal like question mark, we can replace it by 9, right? Like in all cases, it can be 9.
Yes.
If time of 0, 1, 2, 3, 4. If time of 4 is equal question mark, replace it by 9. Can it work? The last digit. If it is question mark.
Yes.
Yes. So here this needs to be.
Like if time of 4, time of like 4 is question mark, then we can replace it
with 9.
With 9.
Yes.
Yeah. Okay. If time of
4 9. Yes.
Yeah. And I think we also have to check like what if there is a question mark at 0 and 3.
Yes.
0 and 3, like which case? Can you give us an example? Which case?
At this place, at this index, and at this index. So like suppose if we have our input like question mark 5 and question mark 5, like this. So here we can only have 1. Here we cannot have 2.
Yes, exactly.
Yeah, and here at best we can have 1, 5, 55.
Yes.
Okay. Yeah, so this is for index 1. This is for index 4.
Yes.
So now we will do for index 0. Time 0 is equal to question mark. And for this we will have to check this character also.
Yes.
So if time of 1 is greater than or equal to 5, then time of 0 needs to be 1.
Yes.
Else if, I think first we will have to check the question mark condition. Time of 1.
Yes, true.
Else time of 0 is equal to 2.
Yes, right.
Right.
Okay. This is index 3.
Yes.
In this our condition will be if time of 4. I think here we have no condition, like we can directly place 5.
Yeah, exactly.
Yeah, so if time of 3.
Yes, we can.
Time of 3.
We can make it 5. And I think also for index 4, if I am not mistaken, there is no condition. We can do the same thing for index 4, can we?
Yes. Yes, I think we can directly place.
Yeah, like index 3. Yes.
Yeah, so time of 4. Yes, so here we can directly place 9.
Yes. There's some compile error. Can you scroll it? You can see the output.
Yes. Yes, we
okay,
have to return.
Return.
Yeah, so we will directly return time.
Yeah. Yes, I think.
Yeah.
Yes.
I think I'll submit. Okay, here it is giving.
Yeah, so it's not 5, it is 4. I think we cannot be
Next.
24 for the first case.
Yeah.
Yes, it should be 4.
But
Make it less than equal to 3 or
yes, I think it will be greater than or equal to 4.
4,
Yes, correct.
It's the one edge case. Yes.
Yeah,
okay.
accepted.
Cool. So let's move to the next question and discuss it.
Yes. Oh, yeah, this is the second question. So we are given 2 strings A and B that consist of lowercase letters. So in one operation, we can change any character in A or B to any other lowercase letter.
Okay.
So our goal is to satisfy one of the following 3 conditions. Every letter A is strictly less than every letter in B, and every letter in B is strictly less than every letter in A. Or both A and B consist of only one distinct letter.
Okay.
Yeah. So in this example, like we have ABA and CAA. So as per the third condition, as per the given 3 conditions, we have to either make A strictly less than B, like every character of A should be less than every character of B.
B, okay.
Yeah, so like in this, if we have A here, so all characters in this should be less than A. So to satisfy the first condition, we will have to change like characters in both the strings.
Okay.
Yeah. So in this, the answer is 2. We can change B to CCC in 2 operations. We will change this character and this character.
Okay.
So after making these changes, then every letter in A is less than every letter in B.
Okay.
So our condition is satisfied. So the answer for this test case is 2.
2, yeah.
Like we will have to change these 2 characters. They have given some other alternatives also, like we can change A to BBB and B to AAA.
Okay.
Like we will change this character one operation and we will change this A and this A. Okay. Operations. Yeah. So then we will have this situation, like every character in B is less than every character of A.
Yes. Okay.
Yeah. And the third one is we can change this string A to AAA in one operation. Like we will change this B to AAA, and we will also change B to AAA. So this one, this C will change to A. Then both the strings will become equal, and we will satisfy this condition.
Okay.
Both A and B consist of one distinct letter.
Yes.
Yeah, so best possible is 2.
2, yeah. And let's take the second example. And in this case, the best way to make condition 1 is true by changing B to EE. Okay, so if you change B to EE, so so what happens is...
every character of A will be less than every character of B.
Yeah, exactly. So we have the string length of 10 power 5. So we have to do it in linear time complexity, not more than that, right?
Yes.
So how would we approach this problem? Okay. So we can they might not be of the same length, right? They can be of different length. Yes.
Yes, they can be of different length.
Okay.
This third condition requires us that both the strings have only a distinct character.
Like all the characters are same.
Yes.
Okay.
Like the length does not matter.
Okay, so like we can have one condition, like we can check the condition 3. If like both A and B consist of only one letter, then we have the solution. There's like we don't need to change it. Or we can, so I think for every case we can try and see how many letters we need to change, and then we have a global answer, and that will take the minimum of all the answers, like answer from each case.
Yes.
Okay, so let's go to this Google Doc and try to like doodle our solution and think. So our approach will be like try all the 3 cases and see how many letters we need to change for each case, and then get the answer, something like that. Okay. What do you think, Saurav? How would you?
I'm not getting a way. Like I think checking all the 3 conditions will work. I cannot think of any optimized way.
Okay. Okay, fine. So we can check all the 3 conditions. So for condition 1, how can we get the optimal like solution for condition 1? Yes, so every letter in A is strictly, so we can check. So we can find out the maximum, like the biggest correct letter in A, and find out the biggest character in letter B, and see like like how is it strictly less or strictly larger, and then compare, something like that. Or what do you think? How would you solve this problem? Chidres, like what is your solution? Let's go through your...
Yes. So as you said earlier, for this third condition, I checked with all the 26 letters. Like what is the minimum operations required to change this ABA to AAA and this CAA to AAA. Like for all the 26 characters. So this operation can be done in order of n time, or 26 into n time. And for these 2 conditions, I use the similar approach. Like suppose this ABA and CAA. So I selected one character, let's say J.
Okay.
Like for example, if we have that character J, we will check like how many changes need to be done in A to make all characters less than J, and then how many changes need to be done in B to make all characters greater than J.
Just give me 1 minute. I need to upgrade the loom. Like the meeting because we will be logged out in some time. Okay.
Yeah. Yes, so we can do this operation in order of n, like the third condition. And like for first condition, what I tried was, for this first condition, I took an alphabet from A to Z.
Okay.
Let's say like we are at some alphabet H. So if we are at alphabet H, what we think of doing is we will make all characters of B greater than or equal to H and all characters of A less than H.
Okay.
Then this condition will be satisfied. A is less than B.
Yes. Yeah. Like we try all the combinations. Like for every letter in the alphabet, we try to like minimize A like less than that and B greater than that, and then get the answer. Yes.
And for second condition, we can do the reverse. After selecting a character, we will make all characters of B less than that and all characters of A greater than that.
Yes. I think if you like sort the A and B, that can be bit simple, right? And do kind of binary search and find out how many letters are like how would you implement that? Like how many letters you need to change? Yes. So let's see the solution. Yes. Okay.
So at beginning, I consider like answer as to be a very big integer value. Then I took answer as this make function returns the number of steps we have to take to make A less than B.
Okay.
So make AB means we will make A string A less than B, and make BA means we will make string B less than A.
Okay.
Yeah. So here is this function. So here also I'm taking the answer as some big integer value, and now I'll start from character CH B to Z.
Okay.
So what we will try to do is we will make all characters in A less than CH and all characters in B greater than or equal to CH.
Okay. Okay. Yeah, it will just take 26 into the length of the string, so it will be O end of time. Yes. Okay.
Yes. So this is the temp variable like for every character, and like in 26 iterations I'll update this local value.
Yes. Okay.
Yeah, and we will return this local. So this is for the first two conditions.
Okay.
And this is for the third condition where we try to make both the strings having only one distinct character.
Okay.
Yeah.
Nice.
So this is A to Z.
Yeah, good solution. Okay, let's move to the third question that you solved.
Yeah. Yes. So this is a matrix solution. Okay, I'll explain it using some MS Paint. Okay. Okay, so what it says is we have this matrix of numbers. Okay, so this is a 5 into 4. This is a 5 into 4 matrix. So first we are given this matrix with numbers, and we have to replace this cell with exclusive OR of some numbers.
Okay.
So like this cell will be replaced with exclusive OR of let's say this cell. So this cell will be replaced with exclusive OR of all these numbers.
Okay.
All these 9 numbers, and this cell will be replaced with exclusive OR of all these numbers.
Yes. Okay. Makes sense.
So after making these changes, we will have like n into m different values. Like from all these cells, we will have n into m different values, and we have to return the kth largest value in this matrix.
Okay.
Like which we get after making those changes.
Okay. I think we're thinking something of like we can like something of dynamic programming.
Yes, I use dynamic programming in this.
Yes. Like you can calculate the previous like the to compute. So let's try to example the how to solve it using dynamic programming, and then we can drive in the code.
Yes. Yeah. So for this first cell, we can directly have the same value. Like it will not change.
Okay.
Yeah. And for calculating like a value in this cell, like in the first row, we can use the previous cell answer. Like for calculating this, we will make use of this answer.
Yes.
Yeah, and same for like this column. If we have to find like for this, we will make use of this this pre-calculated value.
Yes.
Yes.
And yeah, and for like finding answer of this, I use this value. Like for like a cell like this, we will have to take this answer. Then we will also need to take this answer. And like this answer is repeated twice.
Yes.
So we will also need this answer.
Okay. So maybe you can write how to find ij from like if you have all the solution of dp i-1 and j-1, how you'd find like ij relationship between, like you can write it.
Yes. Yeah. Okay, so let's say we have a n into m matrix. So at the very first cell, like I equal to 0 and then j equal to 0, let's say the matrix name is A.
Okay.
Yeah, so in this situation, and let's have the answer matrix is this.
Make it input matrix and dp matrix, so then we'll understand easily.
Yes,
Yeah,
okay.
Input matrix and answer is like dp matrix. Yes,
dp. Yeah. So if I equal to 0 and j equal to 0, so dp of I, j will be equal to input of ij.
Yes.
If we are in the first row, so we will say dp of ij is equal to dp. In the same row, we will move to the previous column.
Yeah, ij
So
minus 1.
j minus 1. Yeah.
Zor
In
of
exclusive or
yeah.
input of ij.
Yes. Okay.
If we are at the first column, so dp of ij it is equal to dp in the previous row, but same column, exclusive or with input ij. Now in rest of the situation, what we will do is dp ij is equal to dp the previous row, same column, exclusive or dp the previous row, the same row, previous column.
ij minus 1, and then we have to again zor it with dp i minus 1 and j minus 1.
Yeah. And now we will move one row back, one column back.
Yeah, dp
so dp of I minus 1, j minus 1, and finally the current number.
Yes.
Yes.
Okay.
Yeah. These are the 5 conditions.
Nice.
4 conditions. Yeah.
Okay, now I think we can see the code right now because we understood the logic. It will be easier to understand the code base. Yes.
Yeah. Yes, so here I'm storing the values of n and m, and this is this T is our DP matrix.
Yeah.
So I'm sorting all this. No sorting here. Implementing that logic.
Yeah.
I'm calculating that DP matrix, and what the question says is we have to return the kth largest value after this.
Yes.
So along with calculation, I'm also pushing this into this vector.
Yes.
Like this vector will store n into m values. Yeah. So after calculating, I'm sorting this and I'm returning the kth largest.
Okay.
Kth largest number.
What will be the time complexity for this?
Yes, the time complexity of this is n into m. Calculating this, and this sorting will be n into m log of n into m.
How can you improve it?
Priority queue.
Yeah.
The sorting can be improved with a priority.
So let's write down the time complexity here for this solution.
Yes. Okay. So this is order of n into m. Like this part.
Yes.
Calculating the DB matrix. Then now our vector, like this vector all, it has n into m values. So sorting this takes order of n into m into log of that value n into m.
Yes.
And then we will be returning the kth largest.
Yes. Cool. So, how can we, what will be the time complexity if we use a like minimum heap, min heap or max heap? Kth largest. So you have to use we can use a min heap, right? And find out the maximum.
Yes.
Okay.
Yes, but I think if the value of k is n into m, then we might have to store a heap of size n into m.
No, we can just store a size of k, and like we can have a minimum heap. Like let's write down. We can have a minimum heap.
Yes. Okay. So
we can have.
I'll write in Google Docs.
Yeah. Okay. So we can have a minimum heap.
We can use min heap. Yeah.
Min heap of size k.
Yeah. Yes, but like this k can be equal to n into m, the largest value. Like if we want the largest value.
Yeah, but still it will be like the worst time will be n into m, not n into m into log n into m, right?
Yes.
Okay.
I mean, it doesn't matter. So like you pass the test case, but obviously we can improve it. And if you use a minimum heap, I think it will be better. Okay,
Yes.
we don't have to implement that. Just it's for the video. Like people can implement it in the better way.
Yeah.
Okay. Okay, so we'll take a break of 5 minutes and then we will solve some Leetcode problem. Okay.
Yes. Okay.